All right, guys, get excited. This is the last official lesson for the year. The last thing we're going to look at when it comes to circles are the actual segments. We've been working a lot with chords and tangents and secants and the angles that they make and how we find those angle measures. This last lesson is going to be, well, what about all of the segments that they make and how can we find the length of those segments? So really there are three things we're going to look at, and so we'll sort of take them one by one. So the first one is what happens if you have two chords. So you can see in the picture there that when you have two chords and they cross each other, you really are getting four segments, right? Each chord is split into two pieces. So the key is, how are they split? What relationship is there? So if we have two chords, and so one chord has parts A and B, the other chord has parts C and D, we can say that A times B equals C times D, okay? And if we use that setup, A and B, remember, are two pieces of the same chord. C and D are two pieces of the same chord. So the key here is you are multiplying the two pieces that are on the same line. So if I go over here to my example and I take that approach, so 6 and x are on the same line, so I would need 6 times x. 3 and 4 are on the same line, so I need 3 times 4. You could obviously do that multiplication before you even write it down, so you could have just started with 6x equals to 12, right? Either way, we're looking at, okay, simple division, right? And simple division tells me that x is 2. So this segment in my picture would have a length of 2. Okay, so two chords crossing inside a circle, multiply the two pieces of the same chord together. That's how you're going to set up your equation. The next option is, well, what happens if instead of being two chords, I have two secants, and those two secants are meeting up at that point outside of our circle? What this means is now my secant has a part that's inside the circle, a part that's outside the circle. And so that's what's getting labeled. You have A and B again on the same line, part inside, part outside. C and D are on the same line, part inside, part outside. They give the setup as B times A plus B equals D times C plus D. And while you can use these letters to remember, to me, there's a much easier way to remember using actual words. So think about where B is in the picture. B is the part that is outside the circle, right? If I put A and B together, that's giving me the whole line. So really what you're doing is you're saying, okay, take the part that's outside times the whole line. I just realized I spelled that wrong. There we go. And so the same thing is actually happening with the other one. D is my outside. C and D together make the whole line. So instead of worrying so much about A, B, C, D, the phrase you want to remember is outside times the whole line. That's going to give you your setup. That's going to work for you every single time. So if I take that approach over to this picture, 2 is outside, 2 plus 12 is my whole line. X is outside, X plus 3 is the whole line. Okay, that's what we are looking for, right? So you can put this, I can say, okay, well, 2 plus 12, I can go ahead and put my 14, right? Or I can distribute and I can say 2 times 2 is 4, plus 2 times 12 is 24, right? Either way, so whether you're doing 2 times 14 or here 4 plus 24, either way, this is going to give you a 28. And can you have one of those two lines in between here? Absolutely, right? On the other side, you are going to need to distribute that x. And so that's going to give me an x squared equal to 3 times x. Or sorry, not equal, plus 3x. okay? At this point, we have our x squared, and what we should remember is that if we have an x squared, that means I'm probably going to need to factor because I also have this 3x, and in order to do that, I need set equal to 0. And in order to do that, I need to keep that x squared positive. So we're going to subtract 28 from both sides. If I subtract 28, there's my 0. I've got my x squared plus 3x minus 28. And so that's what we need to factor. And so remember, when we're looking at factoring, you're looking to find the two numbers that multiply to negative 28, add to positive 3. So if I'm doing this, I'm going to get the value 7 and 4. Because I need a positive 3, we're going to get a positive 7, and we're going to use a negative 4. 7 times negative 4 is negative 28, but 7 minus 4 gives me the positive 3. And then remember, it's about getting those individual values for x, right? So if it's helpful to say, okay, well, if x plus 7 equals 0, and if x minus 4 equals 0, and to solve your two equations, then go ahead and do that process. Ultimately, you want to say, okay, well, x equals negative 7, and x equals positive 4. Because what we are finding is the value of x, and if you go back to your picture, x is a segment length. Does it make sense for a segment length to be negative? No. So we're going to need to say, guess what? Negative 7 doesn't work. The only one that works here is positive 4. Because x is representing the entire segment, negatives don't work. This doesn't mean that every problem you do of this is going to factor, but because of how we're doing this outside times the whole line, factoring is something that will happen occasionally on these questions. We've got one more option to look at, and this is when you have a tangent in a secant. So remember, a tangent is entirely outside the circle. Your secant is where you're going to have part inside and part outside. So we've got parts A, B, and C. We have no D this time because we don't have 4 parts. There's only 3. So they give the setup as A squared equals B times B plus C. I don't want you to, again, worry so much about that. I want you first to realize that A squared is really taking A times A, right? A times A is A squared, yes? So because of that, think about where A is. And if I go through that same process as I did on the last question, A is outside my circle. A is also the whole line. B is outside my circle. B plus C is the whole line. So the same setup that I just used on the previous question, I get to use on these questions as well. So this is why I'm saying don't get hung up on A, B, C, D. Look at the picture. What are you looking at? If you have part inside and part outside, the only phrase you need to remember is outside times the whole line. So I'm going to take that approach over to this question. So x is outside, x is the whole line. 4 is outside. 4 plus 5 is the whole line. So x times x gives me my x squared. 4, and then you have 4 plus 5, right? Well, 4 plus 5 is 9. 4 times 9 is 36. So I do have an x squared here, but notice I don't have a single x. I actually just have x squared equal to a number. And so that means I can just square root each side. I don't need to factor. There's nothing to factor because I don't have that single x term. And so if I square root, x is simply 6. Depending upon where x falls in a question like this might require factoring just like the previous question might not. It's all very dependent on which one of the segments in the picture have your letter x that you're solving for, okay? The next video is going to just be a few more examples of all three of these types, but these are the three setups and the three ways that this will work.